Good morning, everyone. Today we're going to talk about the conservation of mass. During the 1700s, Antoine Lavoisier and his wife, Marie Anne, discovered that the total mass of reactants is always the same as the total mass of the products in any given reaction. Another way of saying this is that the mass is always conserved. This is known as the law of conservation of mass. The law of conservation of mass implies that no atoms are destroyed and no new atoms are produced in chemical reactions. Instead, the atoms in the reactants of the chemical reaction are simply rearranged to form the products. The rearrangement of atoms that occur during a chemical reaction can be illustrated using models or diagrams. Consider the reaction of hydrogen and oxygen gas to form liquid water. The equations for this reaction are, so the word equation is hydrogen plus oxygen, react together to produce water. So this little g and this little g means gas and this little L means liquid. This is the chemical equation. So we have hydrogen 2 gas plus O2 gas come together to react and produce water, H2O. So does this diagram follow the conservation of mass? So just remember, we just talked about this. It is about how atoms are not created or destroyed, okay? So that means I need to have the same number of atoms on this side of the reaction as I do on this side. So let's count them up. All right, I'm going to put our oxygen here and our hydrogen here, okay? So let's count up the atoms on both sides here. So on this side, we can see oxygen, there's 2 of them. On this side, there's only 1 oxygen. On the left side, there's 2 hydrogens. Okay, and then on the right side, there's 2 hydrogens. Now our hydrogens have been conserved, but our oxygens have not. So at this moment, this diagram does not follow the conservation of mass. In order to agree with the law of conservation of mass, the numbers of atoms of the reactants must equal the number of atoms in the products. So that means, we need more. So that means there needs to have been more. So when I look at this now, oxygen and hydrogen, all right, I'm going to see I have 2 oxygens here. Then on this side I have 2 oxygens, so that's right. And over here I have 2, and this is 4 hydrogens. And then on this side, that means I have 4 hydrogens as well. So this is the correct chemical equation. Both sides, are equal. They have the same number of atoms. So this is the correct equation and the correct reaction. When the number of each kind of atom is the same on both sides, the equation is said to be balanced. And that's the goal. The goal is to be balanced. The law of conservation of mass has implications far beyond the laboratory. Think about engines that use fuel as a source of energy. When the car burns gasoline, energy is released during the chemical reaction of combustion. However, since the mass is conserved, all of the mass of the fuel is still present in some form after the combustion occurs. For every kilogram of fuel mixed with oxygen in an internal combustion engine produces 3 to 4 kilograms of water vapor and carbon dioxide gas, as well as pollutant gases such as nitrogen oxides and unburned hydrocarbons. And what that means is, even with those reactions, it is still being conserved. They're just in a different form, but the atoms remain the same. So you don't lose or gain any atoms. So that's the end of this video. Our next video will be about balancing these equations.